Hey guys, it's Vince. Today in this video we are continuing with yet another video in the series. We are on volume 17 now of the CNC fail category, and I cannot emphasize enough, if you're just getting involved in watching these series, I suggest you start from the beginning, only because you're going to see that evolution and the pattern form of what's to follow as you get later in the series. This is an interesting video because, again, it's going to cover a topic I haven't discussed yet. It does come up every now and then, but I definitely want to cover it because it's something I feel is going to help many of you as you're getting involved with the CNC genre. Let's jump right in. Okay guys, what we're seeing here with this type of router is one I've never discussed on any of my CNC fail videos. Let me explain. This is one that's actually using a small DC spindle. Now, a question that comes up, it doesn't come up that frequently because I feel most end users realize that they're limited in the amount of jobs that they can produce with such a small spindle, but they still come up, is am I limited in using an Arduino GRBL or other 5-volt USB motion controller if I utilize a small DC powered spindle, 100 watts, maybe 300 watts? And the answer to that question may surprise you, but you can use Arduinos with low amperage draw devices. Now, that being said, and I'm going to break this down carefully in this video because it's a good video to really cover where the details can get skewed. You are not nearly as susceptible to EMI with a small spindle like this, mainly due naturally to the amperage draw that we see on the larger AC type units running 220, 110, or wood routers, which are extremely horrible in terms of dispersing EMI because, once again, they're not designed for robotics use. But things get kind of in a gray area where guys will assume that we can cut corners on general assembly. That's where this video, I think, is going to enlighten many of you. So, once again, just to cover and reiterate my point, if you're running a small DC spindle, and small means 100 to 300 watts, usually stability will not be an issue with a USB controller due to the fact that we are not generating large amounts of EMI. That's why, if you've noticed, China has been releasing a lot of these smaller laser engravers, and a lot of them are 20 watts. I think some of the higher power ones may go 40, maybe 50 watts, but they're using USB interface, and that is fine because they are not dispersing EMI like a CNC router does. And that's something that, once again, we only see with AC type units. So when you see these type of units, it's amazing. Yes, you can definitively have stability to some degree. And why I say to some degree is we're going to cover in detail where we separate fact from fiction. But overall, this portion of the video where we're covering the spindle by itself, yes, you can use a DC powered spindle, once again, 100 watts, 300 watts, and be okay in utilizing an Arduino or utilizing a USB motion controller and not be fearful, so to speak, of disconnects due to USB, as long as other provisions have been taken to make sure the system is built correctly, and we'll cover that as we go later through this video.
Hey guys, I'm very excited about this video. This thing has been on my bucket list for quite some time now. I'm going to show you how I built this CNC router controlled by an Arduino for around $600.
Okay guys, so we see the YouTube influencer reference the price of the machine. You can see the size of it in reference to his body. So most new end users who aren't veterans in understanding this genre hear the price, they're baited by the price to think, hey, if this guy can do it, I can do it. Once again, he has an audience, so he comes across more as an authoritative figure, and they go out, they drop their so-called $600, and they're usually going to be disheartened because the natural instinct of most end users is to see this size machine and say, you know what? He only did it with a DC spindle motor. I'll just put a larger spindle motor on and I can take and use this unit for even larger applications. And this is a natural level of assessment that most end users looking to get into this field will do. And once again, him as an influencer, having an audience, not respecting his audience to the degree he should, in that he should be clear and not misleading if he truly understands what he's working with. But unfortunately, YouTube just does not have the resources to go through and enlighten people on the truth, and that's where, once again, I will make sure they're held accountable with facts. This unit, in the capacity it's set right now, it's irrelevant the size of the router. What is relevant is the size of the spindle in which he's chosen to delegate that the machine is stable. Now, I said before, it's stable in the sense that the EMI produced by the spindle alone will not yield an unstable machine using an Arduino. However, if there is build problems, which I also stated, that are relevant in this machine, you will also have the probability for instability if he does not know how to assemble the controller, and we'll get into that in a second.
I decided to build my own rather than buy one for a few reasons. The first is it sounded like a lot of fun. The second is I wanted to save money, and the third is I wanted a rather large cutting area.
So how many guys out there listening to what he just said didn't become attracted to that terminology? I mean, he essentially covered in a nutshell what every DIY guy wants. Large table, small investment, and it sounds fun to build a system. I mean, ultimately, that covers CNC robotics to the majority of people who, once again, just do not have the knowledge yet to know all the ins and outs that they should. And it's interesting how these content creators formulate their wording to, once again, be persuasive to those who just don't know yet.
Another great thing about making your own CNC router is that you can rely on freeware, such as this universal G-code sender, which I will be using, which connects directly to the Arduino.
Boy, this just keeps getting better and better. I mean, as you watch the video, in his audience, he then is even willing to share with you that you can use a free G-code sender that, once again, you don't have to buy the typical motion control software for your machine, Mach 3, Mach 4, UC-CNC. You don't need all that. Just go with the free software and you're golden. Guys, please be careful. If you do go with free software, and believe me, I'm a big believer in not spending when you don't have to. You can ask any of my clients. You are basically asking yourself to major limitations. Very few pieces of free software when it comes to production robots is worth using due to the fact that it's either limited in the feature set and it's going to definitively be limited in the support you get. You get what you pay for when you're dealing with production robots. I cannot emphasize that enough. Be wary, especially of any influencer trying to sweeten the deal continuously, one after another. All you get is free software. It's never been paid for. It's updated by whoever created it at will over some period of time, and the only support you have is this huge community that they tell you is online, and you have to get in touch with them, and hopefully they're not overseas. Let me tell you, I've heard it all. And 9 out of 10 times, you will be certainly very lucky if you get stability using that software to any degree, meaning for larger projects, it may work, it may not work. They're not going to tell you that. Be careful. Invest where you should. And be weary of anyone yielding that many free gifts. There are not that many free gifts when it comes to CNC production, because end users and vendors should be aware that you are using this machine to make money. Hobby users are very, very few and far between, and they're typically only hobby users, as I've said in previous videos, until they learn how to generate an income by not only creating the product soundly in a consistent environment, but also then implementing the correct marketing to move them.
All right, let's get started with this build. As you can see right off the bat, there are a lot of...
Okay guys, now we're up to one of the most critical portions in the video, and that is when a YouTube influencer slash content creator puts "see description for links to parts." Now, what I have a problem with, and many of you should have problems with, is whenever an influencer does this and they are not directly correlated to the technology they are working with. Let me explain in detail, because I've had many audience members or people just perusing my channel say, well, you do the same thing. Let me tell you the difference in what I do. As an engineer, I design my own components and I stay in the genre I'm in. No different than if a doctor was marketing the surgery that he practices. That's a lot different than somebody who has no understanding of what they're building or working with, other than to say, hey, there's an opportunity to make money on those that are less competent in the field that I'm discussing. That is deceitful, and that is something that many of you should look at and say, wait, we have a problem with this. This individual is trying to get money as an endorsement affiliate so that he can fund his channel to keep hopefully dispersing videos of this or other sorts, and whether or not he has the knowledge to back up what he's doing correctly, it's kind of irrelevant. Once again, as I stated earlier, there's no way YouTube can go through and validate, or be expected to, every video that's put up. Hopefully more end users like myself, who are genuine end users in the sense that we're in the genre we're claiming to work in, will do videos like this based on their own genre, because it's despicable behavior to try to make money selling any links to components, whether theirs or not, that they do not know, truthfully, if end users will get the same success that they did. And that is, once again, a despicable way, I feel, to make money.
Things that need to be purchased. But don't worry, I will leave a link for each and every one of these items in the description below. Here I've attached a scrap piece of plywood to the back of the gantry to hold the electronics.
So I believe I've made my point. We're going to start to go downhill here real quick. We already see that he's using a piece of wood to mount the electronics. Now, I'm going to bring up some real obvious points of why never to use wood. First and foremost, it's unsafe because it is flammable. You mount any power supply that's taking, once again, AC power, distributing it in DC format, and any type of spark or any type of fallacy could potentially result in a fire. If this is the case, you will not be paid by your insurance company. Check and see if I'm accurate on this. I've had a lot of my potential clients do this and thank me in the long run. That's the first point. Second point is the fact that you cannot ground wood, guys. And you'll also notice that we have anodized components here. Anything that is anodized, and I've covered this in previous videos, is an insulator. So the coating must be removed. So once again, had he been aware of this, this would have been discussed earlier as far as grounding the system. I've actually fast forwarded to the electronics portion because, again, you will see that that's not discussed. The main thing we are looking at here is a disregard for the fact that all electronics for precision robotics, I don't care what size the robot is, if you're expecting it to be accurate, it should be assembled correctly. And this is mandatory. That means that all electronics, as far as the controller itself, any component should be installed in a metal electronics enclosure. Once again, the metal enclosure will act as a proper Faraday cage, protecting from a certain amount of EMI. Also, it protects from the environment that your robot is installed in. These are production robots, which means if you're installing your electronics to the back of the gantry, everything will be covered in dust. Most end users already know this, and for my new guys out there, keep in mind, CNC robots are messy. They're going to produce a lot of debris, and this is to be expected. Logic comes into play here, and once again, with a content creator, this is where we start going downhill. Okay, so like clockwork, once again, this content creator has uploaded his version of an arbitrary wiring diagram. And he provides this to his audience so that they can reference it, and what they think is that they'll achieve the level of success that this YouTube content creator has produced in his video. Now we're going to get to the truth of it. The truth of it is this is a simple diagram reflecting point A to point B connections. It does not indicate using the proper double shielded cables, which is an additional component always left off, and that's why I recommended in the beginning of the video for anybody new to the channel, watch these CNC fail videos, because you're going to find the pattern. And the pattern is that many of these content creators do just this. They'll upload wiring diagrams where they think, hey, I'm giving you the holy grail of connections in terms of assembling the controller, when in fact they're actually missing critical details that make the controller stable. There's nothing on here at all about proper grounding. There's nothing on here at all about using power splitters if required with your power supply. Everything is assumed to be daisy chained, as we see here, because there's just wiring connections going from one connection to the other. He's not showing terminal splitters. He's not covering anything in extreme detail, and the main reason that isn't is because, unfortunately, he doesn't have the knowledge to do so.
Here I've installed all of the electronics on the back of the gantry. This is the 36 volt power supply that powers the X, Y, and Z stepper motor controllers.
Okay guys, now once again we get to see what this content creator has produced for his audience, and you get to see what not to do on your own systems. I cannot emphasize enough, if you do not have the money to do it right, save your money. Be careful who you're learning from. Of course, his Arduino is mounted, but it cannot be grounded. We've got the power supply mounted, once again, dispersing DC power from an AC source on his wood, and he did use some kind of plexiglass mount, I guess to protect the terminals for safety, which is kind of comical considering he mounted this on wood. But overall, we see daisy chaining being done on the drives. He did install a voltage regulator essentially for his spindle, which is how a DC spindle is controlled. It just naturally adjusts the amount of voltage going to it. Higher voltage, when you rotate the potentiometer, makes it go faster. Lower voltage makes it go slower. It's very simple. But again, and I said this earlier in the video, just because you do not need a double shielded cable typical of most spindles that are AC powered for this system, because again you're using a low powered unit and EMI is not so present, you still need double shielded cables for your motor cables because EMI is still present for the motors. So we have to look at where we're going with our systems. And this unit is not even properly grounded. I mean, even at a base level, 5 volts going to an Arduino is very low voltage, and every CNC robot, large or small, regardless of what controller it's using, should be properly grounded. And that's to dissipate any electromagnetic interference known as EMI. If we don't do this, we are subject to those gremlins, so to speak, and then we start having USB disconnect issues. That's the most prominent. You can have usually e-stop issues. They come up secondary to that. USB, what you typically see is a loss of connection, and it can go from in the immediate of doing a cut. You'll notice it in terms of that. You could see a switch being triggered that is not being triggered. I use the term ghosting because that's essentially what it is. And you want to be very careful with who you're learning from. This is simply a disregard for, hey, I'm going to do it right, and it's B, I'm going to get this uploaded because it's easy content and I know it gets searched a lot. And that's exactly what we're seeing here. The more interesting part of this whole thing, just so everyone knows, I'm not disclosing who this is. I never do on my channel, but this gentleman actually has an electronics LLC. At least that's what he's discussing on his channel. And it's more disturbing to think someone with any electronics background wouldn't do more research, of course, before posting something like this. Because again, this isn't a 3D printer. This is a CNC router, and it's unfortunate that more end users will watch his channel and assume they're doing it right, spend the money, and then realize they've created more problems to rectify in the end. So hopefully you'll get more out of this as we watch.
So this one here I'm calling my Y-axis control, which is going over here to the side of the gantry. The center one here will be my Z control, and it comes up and over to the stepper motor for the spindle. And the one here on the left is for what I'm calling my X-axis. It loops around down here, goes into this cable raceway, and all the way back to our X motor.
Once again, the YouTube content creator reflects his lack of knowledge in the fact that he actually appropriated the axis incorrectly. The X-axis is across the gantry. An easy way to remember this, guys, is think of the X letter. It's crossing. So the gantry goes across. That is your X-axis. The long axis of your robot is the Y-axis. I'll put a diagram on the screen. You can review this yourself. You can look it up. Again, I'm not being technical. I'm being accurate. And there's a big difference here when you're trying to, once again, delegate to an audience as you are being recognized as an authority, that you do not even understand the axis of the robot.
Here's how I set the limit switches on these stepper motor controllers. This first one here is the Y-axis. Here's the Z. And back here is the X.
Once again, guys, this content creator has defined his lack of knowledge on the subject. He's associating limit switches with dip switches on the stepper drives themselves. Let's clarify for a minute. Limit switches are actual switches that are installed on each end stop of each axis to limit the motion of your production robot, whether it be your X, Y, or Z axis. Dip switches on the drives themselves for your stepper motors or servos usually are allocated for microstepping settings, meaning to adjust the microsteppings of the drives being produced to your motors, or they can also associate them with amperage settings. They usually associate with just simple hardware settings associated with the drive themselves. They are in no way, shape, or form associated with limit switches. This once again concludes the fact that you guys need to be very careful who you watch and who you become an audience member to, because we know YouTube likes to recommend videos, and it's great that it likes to do that. Unfortunately, it once again doesn't vet the information that it's spreading. So we as a community need to do that, and we all should be held accountable if we're spreading misinformation, especially content creators. I feel we have a different level of responsibility to provide accurate content for our audience. This wraps up volume 17 of my CNC fail video series. Once again, guys, I hope you are learning a lot with these videos. I cannot tell you how many emails I'm getting about end users loving them. I will keep them coming as long as you're interested. The main thing is that we constantly question who we're learning from. If there's no history with who you're learning from, or you find tons of links and videos that are offering for you to buy from affiliate links, you have to wonder where that knowledge actually comes from. You know, I mean, just because they use a component doesn't mean they understand that component at the level they should. And I'm hoping that these videos do nothing more than make you always ask questions, because the more questions you ask when people don't know the answers, number one, it makes them uncomfortable, and number two, you'll usually find out the truth. Thank you all for your support. Take care.